Hi all, good morning. Welcome to AK's Math Academy. So today we are going to see a new chapter of class 12 maths, which is continuity and differentiability. So before moving into exercise, there are some few concepts that we should know about. So we'll go into the concepts and then we will solve the questions. So continuity and differentiability. It's a branch of mathematics which is known as calculus. Now this chapter is divided into two parts. One is continuity and other is differentiability. Continuity. So before moving into it, continuity, by the name itself, it suggests that something needs to be continuous, right? So let f of x be a function. Let f of x be a function. It should be continuous. Now how do we know that it will be continuous? By seeing its graph. So let me draw a graph for you. Let f of x be a function where x is its domain and y equal to f of x. F of x is a function and x is domain and y is its range. Okay. Now see, this is like, for example, let graph of f of x be like this. Okay. Now we can say that it is continuous because there are no breaking points. Now let there be another graph, not for this function, for a different function. Let that graph be like this, by this line. This also is said to be continuous because there are no breakpoints between them. But consider this case, a graph of this case. See, here there are no joints between each lines, right? So that is said to be discontinuous or a not continuous function. A continuous function always have closed lines or closed curves. For example, parabola, it have a closed curve, right? Y square equal to 4ax. And similarly, this one also, like line equations, it also have a closed curve. But this one, it doesn't have a closed, the closed path. So it's said to be discontinuous. And which point is discontinuous? This point and this point. That is known as points of discontinuity. Okay. Now, this point determines if the function is continuous or not, right? So that point is known as point of discontinuity. Now, how do we represent by mathematical equation or by the language of calculus that an equation is continuous or not? By graph we have seen that how to represent. But how do we represent by an equation? And how do we get to know if a function is continuous or discontinuous? In our upcoming exercises, they have said that to show whether equation is continuous, they have given the function and they are asking us to show or prove that the equation is continuous or discontinuous. How do we do that? So before going into that, there is very important point to remember. So see, I have already said you that C is a point of discontinuity. Consider this graph for a function f of x. Now, f of x is a function which having these lines and there is a point of discontinuity which is C. That point C determines whether the function is discontinuous or continuous. So how do we know it? By mathematical equation. So see, we can prove that a function is said to be continuous only if it satisfies this equation. Limit x tends to C, f of x equal to f of C. This is the condition to satisfy the continuity. Okay. So see, limits and all, we have already learned it in our class 11. Do you guys remember? Limits and derivatives. This particular topic called continuity is just an advanced version of what we have learned in class 11. Okay, this is one way to prove or to show in a mathematical equation that an equation is continuous. But there is one more way to prove. How do we prove that? LHL is equal to RHL. This means that left hand limit is equal to right hand limit. LHL equal to RHL. So how do we represent it? LHL means left hand side, right? So see, this is a point C, and what is this left hand side? The point, like the part of the graph which is before it, that is leftmost side, right? So from here to here, it's LHL. And what is RHL? From this point to this point, till where the equation ends, right? Okay. LHL, we will represent it by limit x tends to, since it's going to leftmost side, the values decreases, right? So x tends to c minus f of x equal to, and RHL we will represent it by limit x tends to c plus f of x. This is another way to show that if an equation is continuous. So in our upcoming exercises or questions, they will ask us to show or prove that a given equation or given function is continuous. How do we prove that? There are two ways to do. That is limit x tends to c f of x equal to f of c, and other one is left hand limit equal to right hand limit. LHL equal to RHL. Limit x tends to c minus f of x equal to limit x tends to c plus f of x. It's very easy, very interesting chapter. So we'll go to the most interesting questions in the upcoming classes. So please note it down.